Okay, this is part 2, and we're going to do the exact same thing we did in part 1, but this is easier because you're dealing with metric, and metric is what you're used to. So if I take a look here, Mario owns a strip mall, and so we're going to be dealing with rectangles and circles again, but in metric. So Mario owns a strip mall, which means he's got lots of money. So he's going to fix 20 parking spots that need to be repaved, and he wants to figure out how much it's going to cost and how much he has to repave. Question A says, describe a strategy for estimating the area. Well, the strategy I would use is just figure out the area of one rectangle and then multiply by 20. See how hard this is? All right. So estimating this, we're just going to take the numbers they give us, which are 4.8 and 2.4, and we're going to multiply that, and we're going to estimate that it's going to be 5 times 2, which is 10 square meters. So my estimate for each parking spot would be 10 square meters, and then if there's 10 square meters per parking spot and there's 20 parking spots, that means there's going to be 200 square meters in total. All right? So looking on page, and for you this is page 130 in your yellow booklet. So our estimate is 200. I'm going to write that up here because we don't have it in the room. My estimate was 200 square meters. And let's see how close we really are. So using the exact numbers they gave us, one parking spot measures 4.8 times 2.4. I'm going to use those numbers, and I'm going to put down 4.8 times 2.4, which ends up being, using my calculator, 11.52 square meters. So the actual measurement of one parking area, one parking spot, is 11.52 meters. If there's 20 of them, and I'm going to multiply them by 11.52, that multiplies out to 230.4 square meters. Here's the actual measurement, 230.4 square meters. Here's the estimate, and I've finished. Now, if you knew how much it cost per square foot to, or square meter to pave that, you could calculate what it would cost. This is how simple this is all going to be. So we're not going to spend lots of time on this. I did find interesting that a measure of 13.4 is your width and 6.1 is your length. That made no sense to me, but whatever. Whoever wrote up this book was thinking opposite of me. Estimate the area of the badminton court. Well, I'm going to estimate 13 times 4. Sorry, 13 times 6. I'm good at multiplying, especially these kind of numbers. I take 6 times 10 is 60. I take 6 times 3 is 18. 60 plus 18 is 78 square meters. So I'm going to figure that the area of this is about 78 square centimeters. Figuring out the actual area of the badminton court to the nearest one decimal place is just as easy, especially if I have a calculator. I'm going to take 13.4 and multiply by 6.1. And I'm going to grab my calculator, and I'm going to pop that in there, and it's going to give me a value of, let's try this. Last time I did this, it took me about 13 tries. 3.4 times 6.1, I did it again. Let's try that again. All right, 13.4 times 6.1. And I get 81.74 square meters, but they only want it to one decimal place, and 7/4 rounds down to 7. So there's my answer. There's my estimate and my answer. See how easy this is going to be? All right. I would suggest you pause the video right here, and I would like you to complete these questions. On page 132, the section that is called Try This, I would like you to do questions 1 to 3 and 6, 7, 9, and 10. All right? And while you're waiting, I'm going to play a little tune dedicated to some boys who missed their favorite concert. So hopefully, Mr. McCorster, Mr. Houston, that settled your stomach a little bit. You got a little bit excited there when you heard the beeps. But now you can maybe concentrate on getting these questions done. So like I said, I would pause it here, do the questions, 132, and then move on to the next section. The next section is finding the area of a circle. And what we have here is Gail's family installed a portable pool with a diameter. Now I know your photocopy is not a very good picture of this, so you're going to have to trust me on this. They had a portable pool with a diameter of 4 meters in their yard. The pool left a dead spot where the grass died. So they want to reseed this area of grass. So it says estimate the area that needs to be seeded. Well, there's two ways to do this. You could take, well actually I'm not going to tell you the second way because it's going to confuse you. I would take and estimate that, and I would just say, you know what? Pi is about 3. Well, that's what pi is. It's 3.14, but I'm just going to make this easy. You know, pi times the diameter. And the diameter is 4, right? So that means it's the radius squared. So pi r squared. And that's going to be 3 times 4, which is 12. So the area of the grass that needs to be seeded is going to be roughly 12 meters, 12 square meters. Let me put that down. All right. Then the second part says, and this is really blurry, calculate the area that needs to be seeded to the nearest tenth of a meter. Well, I've already done that. So let's get that out of there. And pi times 4 squared. Oh, wait a tick. I made a mistake. We've got to fix that. Pi r squared. I went the diameter. So let's quickly fix this. So pi times 2 squared is going to be pi times 4, which is, now to get the exact measurement, we better use our calculator again. And we can play the beads again a little bit here while we're doing that. Since being bored while you're waiting for me. And pi times 4 gives me an answer of 12.56 or 12.6. 12.6 square meters. Okay, so again, we're just using pi r squared, and we're using, in this case, metric. Easy stuff. So here's a circular solar blanket has a diameter of 3 meters. Estimate and then calculate the area. Round the answer to the nearest square of a tenth of a square meter. Well, if the diameter is 3 meters, we know the area, or the radius, sorry, is 1.5. So we're going to use the radius of 1.5. Now, estimating 1.5 squared is tough, unless you know that 1.5 squared is 2.25. If you don't, what I would do is I would just go pi times, I'm going to see if that's 1.5. I'm going to go one bigger than that, pi times 2 squared, which is pi times 4. And we're going to estimate pi as 3 instead of pi. So we're going to go 3 times 4, which is 12. And then I'm going to go, so that's 1/2 a unit above that. I'm going to go 1/2 a unit below it and say 3 times 1 squared, which is 3 times 1, which is 3. So the answer is going to be halfway between 12 and 3. So halfway between 12 and 3, there's 9 units, 4.5, so that'd be about 7.5 or so. So the answer is going to be in and around 7, is what my guess is. Now, if you knew that 1.5 squared, and well, if some of you know that, then that's awesome. But 1.5 squared is 2.25. Well, that you could just round to 2 and say it's 3 times 2 squared, which is going to be closer to 12. Okay? So when I do this, and I actually use the calculator, I'm going to get rid of this. Oh, hang on. Delete that. And there's my answer. So pi times r squared, actually when I said this was wrong. Pi times 1.5 squared is 2.25. So that gives me an answer of 6. So I squared it when I shouldn't have squared it. So pi times r squared is pi times 1.5 squared, which gives me an answer of 7.1 square meters. All right, and again, all we did was go pi r squared. The estimating is the stuff that takes the time. Calculating